I've been given a difficult task because the minute you say something is quantum, then people, even those who know science, starts to black out because quantum states, quantum mechanics, all of these are difficult for us to understand. Why? Because in our normal world, we cannot perceive quantum states. So it's only when it comes to particle physics, which we cannot see or touch, it's only there. It appears to be a mathematical way of describing something that we cannot physically touch or feel or see. So the mathematics of it is rigorous. There is no vagueness about it. It has predictions. It has predictions in terms of probability, but those predictions are real predictions, and they show the nature of entanglement, which means particles can be entangled, and it seems they can even be in entangled states at distances which are astronomical. So, this again, in our normal world, we do not understand how it happens, why it happens, and we can only say, yes, we know the laws of quantum mechanics. Yes, it follows laws. Those laws are not only real, we can see that if we have made certain predictions, those predictions will be fulfilled. All that we can see, but it does not mean that I can predict a particle what it is going to do. Now I'll leave this part of physics aside, because the reality is that if very famous physicists, scientists are not able to really explain things simply to us, then we have to assume that there are certain things in the microscopic world that we are talking about, which is something which we, with our five senses, we cannot grasp, but we can compute what is happening there. So we can tell you what the laws of quantum mechanics is, we can say what cannot happen, we can say the probability distribution of certain events, that if I take a sufficient number of examples, they'll follow a probability distribution which has been predicted. All that we can do. What cannot happen, we can say. But what is the likelihood of, say, a particle doing something is not something we can say. Unlike what we can say what a cricket ball will do, for instance. So this is where I'm going to stop and talk about what has been given to me, that why the sudden hype, particularly Andhra Pradesh, about quantum city, etc., etc. What is the basis for this? And I'll start by saying that we should not mistake marketing of a city, the capital of Andhra, for something which has a name, but the meaning of it for this purpose could be very different. Okay, you are talking about a possible future. You want to project that this city is going to be forward looking. You want the world is moving towards technology, computers, increasing use of computation. We are talking of artificial intelligence, all of this. And you want to project this future with a good marketing name, calling it like Silicon Valley, you say now Quantum Valley. Now what it does, it makes people feel that you are looking forward to the future, and maybe there is a quantum revolution in computers which is going to take place, which will then open out jobs, open out the city for much more number of people to come in, increase in the real estate price of the land here, and therefore a rosy picture, which cannot be done by only talking about a capital city. So this aura, the extra hype that you provide by calling it a quantum city, because quantum valley, because you can't call it Silicon Valley. That was done 50 years back. So you lost that opportunity. What do you do now? So these are some of the, I would say, the gimmicks that political figures, marketing figures play to market an idea, and in the guise of that, okay, give Andhra capital a certain visibility. So I have nothing against that, except that to believe that there is a quantum revolution around the corner, how true or not is that? And that's where I want to talk about that today. If we look at practically what we are seeing, there are concept of qubits. As we know, a bit is either 0 or 1 in computers. Binary state, only two states. Either it is off or it is on. It's like a light bulb. It's either on or it is off. Not like a fan, which is a regulator. Okay? You either switch on a light or you switch it off. So, binary is two states, only two states. That is what the digital world really is. It works on a number of devices. At the moment, the millions of bits can be there in a computer. When we started, I still remember, we used to have what is a version of the IBM 360. It was actually a Russian computer which had copied the IBM 360. But at the time, IBM 360 was there for instance, in Kanpur IIT. It was one of the more advanced computers available at the university level. It was something which the IBM sold in very large numbers globally. So Russians had copied it, and in JNU this was available. As to also go to the Delhi IIT at that stage, I had come for my master's thesis work. This we are talking about a really long time back. Okay, this is 73, 74 period. And then there used to be also a computer sold by the British to Delhi IIT. That computer company died later. But these were the computers available. And you will be surprised that a cell phone 10 years back would be much more powerful than what those computers were. And those computers took a room which is as large as this, higher ceiling also, for a machine which, as I said, I can take a machine 100 times more powerful, probably even more, and put it in my pocket now. So that is the development that has come in digital technology. And for us who have gone through that, it's actually difficult when we think back that this is the pace at which computer technology would develop. Something that we had not even thought of. Yes, it would develop. Yes, computers will become bigger and bigger. Now, as somebody said, that the moon landing, the computers used for that is much less powerful than the cell phone you have in your pocket, which is true. So, if we talk about that, computers have come a very long way indeed. But the point is, the distance it has come is not that a qualitative change has taken place in the way computers work. It is simply that we have been able to use, instead of relays which are of this size, which had two states, we have been able to use essentially solid state devices which can then be, instead of this size, be very small sized in silicon crystals that you have, and therefore you have the possibility to encapsulate what you required earlier, large electrical devices you can reduce them to electronics. And that is the miniaturization that takes place in computers. And as you know, now we are talking of how many micron level etchings can be, lithography can be done in order to lay out your chips. And obviously, the more finer lithography that you can do, you can etch thinner and thinner lines. You can make the chips much more dense by putting chips on it, things on it. So this whole way that you have reduced what used to be large computers to with electronics to now more and more dense packaging, as it were, that we have done does not mean any advance fundamentally in the computation, nature of computations we were doing. The nature of computations remain the same, except now that we are able to pack far more computing power into those chips. We can program them in different ways. We can, out of the computation, we can do different things. But the nature of computation has not changed. And I think that's a very important element that we have to take into consideration. That when we are talking about quantum computers, what we are talking about is a use which we cannot understand how it will work. So therefore, the fundamental difference is because we have no way of looking at what possible use of such computers can be, that we are also not able to predict will the quantum computers change the world in a way that we have not thought of before. I will take Richard Feynman, who was the one who predicted, the first to predict. He was a very Nobel Prize winning physicist. He was also a maverick. He did various things. He also went and did archaeology for a little while, looking at Mayan, what are called codexes, which are Mayan. You see, Mayans had a written script. They had science, they had mathematics, they had astronomical calculations. And these were what would be called codexes, which are rolled parchment, essentially. Now, unfortunately, when the Spaniards reached Latin America, one of the first things they did was to destroy whatever existed is knowledge. Because they say this is all evil knowledge. This is knowledge which is not Christian. So at that time, if you remember, there was also in Spain, in Rome, there was also large-scale expulsion, specifically in Spain, of Jews and Muslims from Spain. Again, arguing that they are corrupting. So this, and church was very much behind it. So various things happened. I'm not going to that history. You can read it and see what happened under church at that point of time. So one of the attacks on the Mayan civilization was that this is not Christian. If it is not Christian, it's the work of the devil. So they burnt all the codexes, and till date, only 5 Mayan codexes survive. Of course, they're long rolled parchments, so they're not just one piece of paper. But we know from that, the Mayans had a concept of numbers. They had essentially replicated what we have done as Indian numeral system. They had a place value notation, unlike at that time, Europeans who used to write, if they had to write 20, they would write XX. Okay, they had to write 9, it would be X with what S line in front. If it was 11, it would be line after. So, as you can understand, if you have to do a division, a long division, 3,596 by 7,325, say, then if you had to do it like this, using these numeral system, probably multiplication would be a MTech thesis today, and a division by a large number divided by a large number would get you a PhD. Because that would take that long to do. Of course, they used abacus really for doing those calculations. They didn't do it on paper. But Mayans, as Indian literature also shows, that zero, the place value notation was there in India. And the zero is not writing zero. Zero is treating zero as a number that you can add with it, you can subtract, you can multiply, you only can't divide by zero. That's the only operation we still can't do. That's banned. Okay? But every other operation is possible. You can treat it zero like as if it's another number. So the Mayans had also developed a concept of place value notation. They had astronomy. They had advances well beyond, at that time, what Spanish science was. But they did not have steel. They did not have horses. Unfortunately, North America, there were no horses. They did not have animals which could be used for draft like donkeys or bulls. As a result, they could not militarily face, they didn't have gunpowder, of course. They could not face the Spaniards and they were slaughtered. But the Mayan civilization, if you look at the architecture of the cities, if you look at the size of the cities, if you look at what they had created, probably at that time they were ahead, more ahead than Spain or Italy or Portuguese. And Spain and Portuguese are the one who are, being in the Iberian Peninsula, if you look at a map, that is closer to the Americas than any other part of Europe. So it's not surprising. Could you please put it on silent, the phone? So it is also not surprising, therefore, from European point of view, Spain and Portuguese are the one who first went to Americas. But the fact that Americas were isolated from the rest of the world meant that their civilization might have grown in one direction, but militarily it was not on par at the time with what Europe had. And Europe means Eurasia. It's not just Spain and Portugal. It meant from China, India, Persia, Arabia to Europe. So if you take that, then the destruction of the Mayan civilization meant that all those things were then lost. As an just historical note for you, only 5 Mayan codexes survived the burning that was done by the Spanish. They burnt all the other codexes. 5 survived somewhere, hidden by somebody who later on, 300 years later, it has been found. So Feynman is also one of the persons who could read Mayan codexes, because he had a partner with whom he went to also to see what is there in the Mayan civilization. And there he was, because he was a scientist, he was a mathematician, he was interested in these things. He could also decipher the maths in the Mayan codexes. Of course, others also did it, but he's also one of them. So he became, in fact, one of the experts on Mayan mathematics and science. So Feynman was also, as I said, he also got the Nobel Prize, but Feynman, again in quantum mechanics, Feynman also was the one who first said a quantum computer is possible. Then he was asked, okay, quantum computer is possible, you were saying, what will be the use of that? He said, to predict quantum states. So only thing that a quantum computer can do better than any other computer is not solving real life problems, but solving quantum problems. Now, that is unfortunately the state till today. That even now, though we are talking about quantum computers, qubits, being able to do A, B, C, but in any real life problem till date, quantum computers do not do anything which other computers, what we call classical computers, cannot do. So at the moment, there is no application of a quantum computer which shows that in this particular application, quantum computers is better than other computers. In fact, what is being done when a Google or somebody else builds a quantum computer, runs something, it's a specific problem created to show the quantum computer can solve this better than a classical computer. But what utility solving that problem has is not clear to anybody. So it again becomes like what Feynman had said, quantum computers are better at predicting the quantum nature of the states. So yes, that of course, we take it for granted that because their mathematics is ingrained in the quantum states system itself. But apart from that, there is really nothing that in the macro world, not the quantum world, in the macro world it does, which is superior to anything that the normal computers we have, which we use, that they can do. So that's one part of it. But as I said, to give a vision of the future, to predict, okay, we are going to do something, is good to lift the morale of the people. Particularly Andhra has a new capital. Therefore, do all of this, create a mirage that something is going to happen, and hopefully that some things will happen, whatever extent it is, and therefore he will be able to replicate some kind of computer developments in this place and help his capital state and the land value of the capital state. Let's not forget that, which is very important for all political persons. So that I think is, in some simple sense, is what happened. I also wanted to go back to Vijayawada, and what is my connection is Vijayawada. Well, it's also about computers, because the first computer controlled power plant in the country is actually Vijayawada stage 3. And we had Hitachi control systems over here, which are computer based, to control the power plant. And this was the first implementation in a power plant of digital controls. It was also because N. Tata Rao, who was the chairman of the Andhra Pradesh State Electricity Board, he was actually completely a workaholic and also a visionary. He made various changes in the power plant designs in the country. Most of them were good, some of them were not so good. Always happens with somebody who is trying out new things. But there is no question, he was not only forward looking, but at that time, very few plants in the thermal power plants in the world had digital controls. People are not thinking about it. The only other digital control plant in India at the time was one of the refineries, if I'm not mistaken, which Engineers India Limited as the consultants had floated a specification, and the specification was poor, and they had at least started getting in the oil refineries the concept of digital controls coming in. Also nuclear power plants, digital controls were being thought of. The argument being there are complex plants, therefore, if we are able to back up the normal control system we have with some calculation, we may be able to optimize them better, be more efficient, do it at lower cost. So optimization is something our normal analog control systems cannot do. You need calculations for that. Therefore, digital computers might be useful. This was the argument which was coming in. And Tata Rao, I remember still, the first thing he said, I want single push button start of the whole power plant. Complete automation. One button I press, the whole power plant should be able to start. Why can't we automate it? So that was our challenge, that we had to match Tata Rao's vision at the time, which virtually no plant in the world except a couple of them in Japan had done, and we were supposed to replicate it here. It's not a simple challenge, because we had to first write the specification. We are consultants. So we had to write the specification based on what is available in the world. And that also forced these companies to come and seek collaborators here. In fact, Hitachi had a collaboration with Keltron in Kerala. Keltron were the supplier, were bidding for this control system. Germany had a collaboration with Instrumentation Limited Quota. So different companies had partnered with foreign companies to provide the technology, which was at that time still not available here. But it forced them into collaboration. And we insisted that the local party will bid, not the foreign party. So all of that meant that we also took, I'm using the word differently, a quantum leap in control system. Not that we became quantum, but the control system changed dramatically, because once you go for digital controls, then yes, a lot less size is involved. You don't need a lot of big relay-based system that you have. You also could put into it software to see the optimization is better. You could also see the startup is more smooth. There are a lot of things that you can do, which we didn't, all of that obviously we didn't do in the first plant. But I do remember that is something slowly came into nearly all the new plants that we were dealing with, that we could progressively improve what we had done in Vijayawada. Vijayawada was the first. It was in that sense the guinea pig. But that was Tata Rao's vision, that he could force us at that time. And forcing us is not a problem, but forcing a big vendor like Bharat Heavy Electricals, BHEL, but BHEL also made key systems that they had, also digital control based. And we worked very closely to do all of it. And I'm proud to say Vijayawada turned out to be one of the biggest successes that I have been associated with for a thermal power station. It became a model thermal power station. People came from all over the country to see, okay, here is a running example of a digital control system which works and which works well. And the client is happy with it, the supplier is happy, and I as consultant, of course, did get some credit for that as well. So I'm not unhappy about it, obviously. So that was my long past association with Vijayawada Thermal Station. Thank you. Most people know me for my being in jail during emergency and now in being in jail now. So they don't really know that I've had an engineering past as well. And I still am interested in my engineering. But at 78, I don't think I should be engineering anymore. So the fact that I moved into, just taking a quantum leap here, to move into journalism, so to say, after spending almost 40 years of my life in basically optimization, control system, all of these things. Why did I move into this? Because I felt that as society is changing, we are also changing in a way that we are not appreciating. Particularly when you talk about movements, struggles, that we have to face up to the fact that the communication world, how people communicate with each other and how centers of power or movements, struggles, have to communicate with the people, this is changing. And it is changing primarily the same way that control systems changed 30, 35 years back because of technology. And what was the technology? The technology was the cell phone. That once you move to the cell phone, you are seeing that from merely being a recipient of communication, which is really in some sense completely centralized in the hands of a few media companies. Earlier newspapers, later television. This communication is entirely few to multitude, many. Few companies control communication. They tell you what is news. Originally, every morning, newspapers used to tell us what is news. After television came in, 9 o'clock news started telling us what is news for the next day. So newspapers then had to follow what television had set as the agenda. So I'm discounting radio because radio never in India became that popular because All India Radio people thought was government. And Mrs. Gandhi's emergency did not really varnish the All India Radio's stature. It became an instrument of propaganda and remained for a long time that. But what happened was that with private television, multiple voices coming in, television started setting the agenda for the future. It's also the time when those who have worked the whole day come, have their dinner, 9 o'clock, they have the time to see what's happening in the world. And you are a passive absorber of news. You don't think of news as being something that you are involved with. You think of news as what is being given to you. So, in that sense, both newspapers, television, both have this form of communication which is one to many. They are telling you what the news is. And that set the agenda next day also for the newspapers. What changes with the cell phone is now you have a chance also to mobilize opinion in a very different way. Now, there are two possibilities here. You create opinion for a purpose as an adjunct, as a complement of your struggle. You are involved in the struggle. You want to get that news. You want to say why people in your city, in your state, in your village should be involved with that. What is the benefit to them? That's something you can do also. Or you can do it for self-gratification. I, the great, tell you as common people what I feel about this subject. I am the new voice of God. I am the new whatever avatar. I am the Swami and I can tell you everything in the world. So there are two modes of communication. One for self, just to praise yourself, how great I am. And the other as a compliment for movement. That means you look at the people's needs and you say, how can they be mobilized for what is right? How can I give that to them? How can I give it as an instrument of struggle? I was in Andhra a few months back. When I was speaking, I was talking about, say, Lenin. When he creates the Iskra, he doesn't create it just for as a newspaper because he wants to give bhashan to the people and write. He gave it as an instrument of struggle. How the party, the movement, the revolutionary movement in Russia, later Soviet Union, could be built around Iskra. Not in writing it alone, but in distributing it, printing it, reprinting it in different places. How could this be done? So it was an organizer of struggle. It is an organizer of resistance. So you can look upon this little phone, doesn't cost that much now, as an instrument of struggle or an instrument of self-glorification. So one is completely self-centered. Unfortunately, number of people with this instrument get carried away. They think that they pontificate what they sit in the rooms and do. If they pontificate to the phone, that the world will listen. It doesn't happen that way. Then you are only speaking to yourself. So how those who do not have the power to buy television stations, buy newspaper organization, speak what the government wants to hear, so it automatically gets amplified. What can we do? Our strength lies in the fact that we are many, that we are in large numbers. We speak for the people. We organize the people. The question is, how can we use this instrument today for that purpose? And here I have to say that we have to stop thinking of this as an instrument for me and think about how we as movements can use communication for organizing the people. Now when it comes to the press, and I'm going to end with the how do I look at the press. I feel that the part of the press that I empathize with, where I think I belong, is that which is able to take the voice of the movements to other people. Report on movements. Why am I saying that? In Delhi, for example, when we have, say, workers strike or the farmers come to Delhi, what is the next day's headline? Traffic jam in Delhi, as if all their readers are people sitting in cars and they've got stuck in a traffic jam because the workers are protesting for their livelihood. Not the fact the workers, the farmers, the peasants, agricultural workers have marched from 300 kilometers, 500 kilometers, come by train, come by bus. They are congregating here. Why? Why are they wasting their dihadi, their daily wages? Not one day, but much more than that. Why are they doing this if they do not have an existential problem which they want to place before the people of India? So instead of that, what are they catering to? To the middle class who feels uncomfortable sitting in his car. My God, I've got stuck in this traffic jam for 2 hours for this. Workers. So this is the difference, that when people come, do you portray what they are saying? Do you portray their voices in the media? Or do you take the viewpoint of your Malik, the owner of the newspaper, who hates all these movements and therefore would like to give the picture these movements are bad for the country? So, what is the role that we should play? And this is where I was thinking when I started NewsClick in 2009. My attempt was, can we do this simply? Small number of people. And I wanted only to set this as an example to my media friends, those who are trying to experiment on this, to see whether they would take up these ideas and replicate it. And I would offer them any amount of help they required for that. But over a period of time, yes, NewsClick became somewhat more known. People started looking for it. There is some support available. So instead of my being only an example, I had to become also a journalist, which late in my life I didn't really want. But it was a role in some sense forced upon me by the circumstance that we started it, and as it grew, therefore I had to do also what is required. Yes, I'm very proud of the fact that we did cover the farmers' protests which took place at that time in a big way. We started covering it when it started. I still remember in Rajasthan, in one town. Then when the farmers started the protest in Maharashtra and they marched up to Bombay, we started covering it from day one. It's only much later it came into the front page of every newspaper. But all of this we started right in the beginning. I'm very happy that we could do it. And I think NewsClick has done therefore something which had a role it has played, which whether it is not able to survive, it is shut down by the government as it is at the moment almost, that is not relevant. What is relevant is that we could run a news organization in a different way and showed that this could be done. And it's also true that if people get together in Andhra, in Telangana, you have a proud history of people's movements. If you today want to build people's media, it's possible. If you want to think of how struggles can also merge with that kind of media, how can we do it? I think this is our challenge. To think that social media is only self-glorification, or listening to the Prime Minister, or listening to a few people who they are now calling influencers. Now every Tom, Dick and Harry wants to be an influencer, or as in the capitalist terminology, said we are building our brand. I don't know what it means. So, but that is the, shall I say, when you have nothing else to do and you have no competence, then you want to build your brand. So that's where it seems to be at the moment. It can become an instrument of self-glorification and really getting narcissistic, only navel gazing, or it could become an instrument of struggle and mass communication. I think this is where at the moment we are. We are at a cusp of history, which not in quantum computers, but in terms of communication, we are at a cusp of history where it's no longer possible to muzzle the voice of the people. It's no longer possible to decide what the news is by either a set of capitalists or by the governments, to sit with them and decide what news should go and what news should not go in the public realm. This is no longer possible. But it also depends on us whether we want to take up the challenge and what possibilities exist today, and is it possible for us to create a communication in which those who are activists, those who are in movements, those who are fighting for their rights also are able to organize their voice in a way that it reaches others. And can we do it with solidarity for each other's movements so that we build a different kind of media to contest, not to replace? We can't contest with the dominant view which is being projected by capital and, of course, by the government today, who is in the interest of capital. I will conclude by saying this is not a new challenge. This is a challenge which we undertake when you turn activist, when you join the left, when we say we want a different kind of society. The only difference today is that the new instrument for the struggle is also available to almost all of us today. And how we use it will determine the struggle for our consciousness, which to me is as important as any physical struggle that we do. Therefore, I'll end with this. Yes, whether quantum computing will change the future, I do not know. But at the moment, what we have, in terms of the number of people we have, the kind of technology that is available to all of us, we have the ability, by working together, to make a quantum change in society. Thank you very much.